Hello and welcome to another video. In this video we're going to be doing minimum number of steps to make two strings anagram. And in the problem you're given two strings of the same length, s and t, and in one step you can choose any character of t and replace it with another character. Return the minimum number of steps to make t an anagram of s. An anagram of s is a string that contains the same characters with a different ordering, or same. So in this first example you have BAB and you're trying to make ABA, BAB. So you basically just turn an A into a B. So if we just have something like this, now it's an anagram because it'll have two B's and one A. In the second example, there's a bunch of characters that you need to be changing. And in the third example, they are the same number of characters, you just need to rearrange. So the main thing you need to know for an anagram, for two words to be anagrams, like what is the definition of an anagram? And the definition is their number of each character needs to be equal. And that's pretty much it. So let's actually look at LeetCode and practice for an example. So let's just have those two. So we're going to have, actually instead of an array, we can just write out the word. So for LeetCode, number one, I'll just do uppercase, and practice. So basically what we need to do is we need to get counts for all of these characters. So for LeetCode, we are going to have 3 E's. We're going to have a C, an L, a D, let's put that in here, and a T. Let's put that in here. Okay, so we have 5, 7, I think we're missing 1. Oh yeah, we're missing the O. So O as well. So not in alphabetical order, but this is what it is. We can actually move the D somewhere else just to make it a little bit cleaner. So we have a D as well. Now we have 8 characters. And for practice, so we have an A, we have a C, with 2 C's actually, have an E, P, R, T. So what's that? It's 5, 7. We're missing one more. Looks like we have an I. So once again, not alphabetical, but it doesn't matter too much. So if we are trying to change, basically we're trying to change one of them into the other one, right? So we're trying to change practice into LeetCode. So how do we do that? Well, basically for every character in LeetCode, we have to have that same count. So we can just figure out what characters we're missing, and that's how many characters we'd have to change. So if we actually look at LeetCode, we can count this up, right? So we can say like, okay, we have a D in LeetCode. Do we have a D in here? No, we don't. So we need a D, 1 D. C, we have enough. We have too many, in fact, but it doesn't matter, but we have enough. E, we need 3, we have 1. So we need 2 E's. L, we are missing completely, so we need 1 L. T we have, and O we do not, so we need. So these are the characters we need. And then basically the operations are just simply take all the characters in here that aren't in here, which will just be all the characters that we need to turn into these, and turn them into these. So the number of operations will just be equal to the number of characters that are missing, that are in here and not in here. So we can write that down. So we need number of characters in final word, not in initial word. And then the actual operations we take are pretty straightforward. We can just take every character that's extra in here and change it into one of these. So for example, if we have 2 C's, we can take one of the C's, turn it into a D, and then the other one we need. Then we have a P that's not in here, so we could take a P, turn it into an E, take an R, turn it into an E, take an I, turn it into an O. And then I think we have like one more. Yeah, so we can take the A and turn it into an L. The number of operations doesn't really matter, but you just know like, in order for it to be an anagram, the number of characters has to be exactly equal. So you just figure out like how many characters are in here and are not in here, and that's the answer. And then those are going to be the switches you need to make. And that's actually pretty much it. So we can code it up. So in Python, you can use a counter, and what a counter will do is it will give you a dictionary of every character and its counts. So we can say like s counts equals counter s, and it's imported from collections, but in LeetCode, collections is already like auto imported, so you don't need it. And then t counts equals counter t. And so we can actually print these just to show you. S counts and t counts. So if we actually, and just return 1 for, so it doesn't crash. So if we actually print, misspelled. If we actually print, you can see that it will basically give you a dictionary for all of these, right? So S counts is these, and you can see that that's correct, right? So for LeetCode, it has 3 E's and so on, so on, so on. So that now that we have that, we can go back. So basically what we need is every character in S and not in T. So we'll just have a result variable, and we'll just say for key in S counts if, and the nice thing is these dictionaries are also default dictionaries. So if you try to access a key that doesn't exist, it will just default to 0. So we can say if S counts key is greater than T counts key, right? If we have more of some character in the left than the right, just give me that difference. So we can just add that difference to the result. So like if there's 3 E's in S and there's 1 E in T, we can just add that difference into the result. And finally, return result. And get rid of these print statements. So we can, submit now. And you can see this works. So this is how to do this. Now there is a one-liner solution, so we can code that as well, just so I could show you. So basically, you can do a counter difference, and what a counter difference will do is, let's say a character isn't in S and is in T. When you do a counter difference, those characters won't count. So for example, if there's a character like, let's see here, R in practice that's in T, and it's not in S, that character won't remain. So we can actually print that as well. So we can print, just to show you, counter S minus counter T, and just have some arbitrary result. So this is basically going to be all the characters that we have that are missing. So these are the characters that are missing. So we're missing 2 E's, and you can see from practice we are missing 2 E's. We are missing an L, we're missing an O, we're missing a D. So that's like a really easy way to do it. You will get all the characters that you're missing and their counts. And now instead of printing this, we can actually just return the sum of all of these values, because all of these values are basically the number of characters that are missing. So we can just say this whole thing is a dictionary, this difference is a dictionary, then we can just do values. And this is going to be values as an array, so we can just return here. And this should also work. And you can see it does. So that's one-liner, that's a normal one, either one is fine. And the nice reason for doing this is, as I've said in a bunch of my other problems, the space here is going to be really good. So the time complexity is, let's say S is the length of S and T is the length of T. That's just going to be S plus T, right? We're just iterating through both strings. Can't really do anything about that. But the space is going to be O of 1, because if it's only lowercase English characters, these strings can be as big as you want. The counter will only have 26 characters max, right? So this counter will have 26 characters. This counter will have 26 characters, and this difference will only have 26 characters max. So that's why using dictionaries of characters is very, very good for complexity, because it's basically O of 1 space. So it's better than like if you had a choice between using this dictionary or a sort, the dictionary is going to be way cheaper for you because it's O of 1 space, or O of 26, you can say, and a sort is going to be like n log n for a really big number. But yeah, so I think that's going to be all for this one. Pretty easy one, as long as you kind of understand like what the definition of an anagram is. And if you did like this video, please like it and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.